You're given 2 points, P and Q. How do you determine the line that goes through these points? How do you actually determine the point direction form of this line? Now, we learned that the point direction form requires 2 things. First of all, you need a position vector that points to a point on the line. Then you need a direction vector that, from this point, points in the direction of the line. These 2 things, the position vector and the direction vector, they describe the line. Now ask yourself in this example, what would be a good choice for a position vector as well as a direction vector? Now, for the position vector, there are 2 obvious choices. You could choose the vector that points from the origin to P or the one that points to Q. We are going to with the one that points to the point P. For the direction vector on the other side, well, we choose the one that points from P to Q. This is our direction vector. Now in this case, the point direction form of this line is just OP plus T times PQ. And you're actually almost done already at this point. All you have to find now is the component representation of OP and of PQ. But that's pretty easy. So this one here, well, it's just given by the coordinates of the point P. So it's 4, 0, 2. And then this one, well, this one, let's have a look. So here you are at this point and you need to get up here. So you go back to the origin up here. So it's minus OP plus PQ. And that's minus 4, 0, 2 plus 0, 2, 4, which then is minus 4, 2, and 2. That's your direction vector. Putting this all together, we get 4, 0, 2 plus T times minus 4, 2, 2. Right, this point we are done. One more question though, is this the only solution or are there other solutions? The answer here is yes, there are other solutions. In fact, there's an infinite amount of solutions because you could have chosen any point here on this line as your starting point. So you could have chosen any position vector that points to a point on this line as a starting point. And then also any vector that is collinear to this purple one as your direction vector, right? So let's just give a couple of examples. For instance, let's call it G1. X, Y, Z is equal to. Now let's start with another position vector. Let's start with OQ. So we start at the point Q. And instead of using the vector PQ, we just use the inverse one. So the one pointing from Q to P. So it's plus T times QP. Right? Using the components, that's just then 0, 2, 4. And the vector QP, well, since it's the inverse one, this is 4, minus 2, minus 2. So that would be a second solution. Let's have even a third one. We denote it by G2. G2 is X, Y, Z equal to. Now, let's start with the same position vector again. We go to point Q. But now, instead of going into this direction, we just use the vector PQ. Yeah, so it's okay if we go up here. So it's plus T times PQ. Also, this gives you a solution. And using the components, plugging in the components, we get Same vector here, it's 0, 2, 4, and PQ is then the one up here, so plus T times 4 minus 4, 2, 2, right? So G, G1, and G2 all describe the same line in the space, this line here, but there are 3 different solutions for the same line. Now, last question here. What happens if you plug in a value for t? So let's say you plug in the value 1 in each of these solutions. You then get the same point. So quickly think about this. Do you get the same point? The answer is no, you don't get the same point. Justification for that is, well, let's look at it geometrically and then also do the calculations. Geometrically, here if you plug in 1 for t, well, you get OP plus PQ. So it's OP plus PQ, so you should end up at the point Q in this case. Let's quickly confirm this. So plugging in t equals 1, we get 4 plus minus 4, so which is 0, 0 plus 2, which is 2, and 2 plus 2, which is 4. And that's exactly, these are the coordinates of the point Q, so 0, 2, 4. Right, now in this case here, what happens if you plug in 1 here? So if you plug in 1 here, you get OQ plus QP. So OQ, you're up here, plus QP, you go down here, so you should end up at the point P. Let's quickly confirm that. T equals 1, so it's 0 plus 4, 4, 2 plus minus 2, 0, and 4 plus minus 2, 2. And these are the coordinates of the point P, so 4, 0, 2. Last one, here, again, if you plug in 1, this will be OQ plus PQ, so checking this one, so it's OQ, and from here we add this purple one, so we will end up somewhere up here, so it's not in the sketch anymore. We don't see that, but arithmetically this would be 0 plus minus 4, so it's minus 4, 2 plus 2, 4, and 4 plus 2, which is 6. So this would then be the position vector of the point up here.